So we're going to continue our work of maximizing, and today we're going to put on some borders to these rectangles. So we have borders. Gardner has 80 feet of fence. It says that she's going to be making a walkway around the rectangular garden that's 3 feet wide. So we're going to start our work the same as we did last time. We're going to get 80 feet of fence. Here's 80 feet of fence. We're going to chop off a piece X, and we're going to build the left X. Chop off another piece X, build the right. And then we have to figure out how much fence do we have left. And the answer is 80 minus 2X. But we still have yet to build a top and a bottom. So we have to divide the remaining by 2. They each get divided by 2, so that's 40 minus X for the top and 40 minus X for the bottom. Okay, so this is the rectangular area. This is the garden. This is the garden. And onto that garden, since this is all mud and dirt, we're going to make a walkway around the garden that's 3 feet wide. So here is the walkway. Okay, and this walkway here, right here, that's 3 feet wide. And this one over here, this is 3 feet wide. Here, 3 feet wide. Good thing I'm putting labels because this isn't drawn very much to scale. Okay, whenever you add on a border, like a walkway or a frame or whatever, okay, let me just put a little note right here. We are always make sure that you state the new length and width. So what that means is I want you to take a look at your picture and I want you to express the new, the big width. Okay, it used to be X. Watch my fingers here. This used to be X, but then I got a little bit bigger. So how wide is it now? It was X, but now it's plus how much more? X plus 6. Okay, I want you to immediately do that with the new length. Okay, so this used to be 40 minus X, but it got a little bit bigger. So what's 40 minus X plus 6? That's 46 minus X. Okay, so a lot of this is going to be very similar to what you did in the past. You're going to make the rectangle, but you have to add a border, and then you have a new length and width. Okay, and you have to be very clear about what's going on. The little rectangle inside is garden. The big rectangle is the entire area, garden plus the walkway. All right, let's make sure we read these directions very carefully. It says write an equation that represents the total area of garden and walkway. So does that mean the little rectangle or the entire big new rectangle? That's the entire big new one. So A of X, which represents total area, is going to be the new width, X plus 6, times the new length, 46 minus X. Now, in your experience here, do we have to multiply this out? In order to maximize using the H and K formulas, we need an ABC. So yes, we are going to have to multiply this out. So A of X equals, firsts are 46X. Outers is minus X squared. Inners, 46 times 6. You might have to crawl in the corner over here and actually do 46 times 6. 6 times 6 is 36. 6 times 4 is 24. 5, 6, 7. So the answer is 276. That's a positive. And last is minus 6x. So A of x, written in descending order. Let's start with the negative x squared. And then we've got 46 minus 6, oh perfect, plus 40x plus 276. Okay, so this is an area equation, and I'm just going to make sure I label this here. This A of x equation represents the total area, Graph the equation and label the axes. Okay, we're always going to draw quadrant 1, of course. And are the axes x and y? Well, look at your equation here. I see x and I see a of x. So x and a of x. And what does this a of x equation represent? Okay, it represents the total area. So sometimes your equations are for garden. Sometimes they're for walkway. This equation is for total area. Okay, the x, where's the x? Where's my picture? Where did I put x? Here's x. Okay, what does x represent? That little x represented that piece. That is the side of the garden. Maybe I'll say the width of the garden. The width of the garden. You have to be very clear which width you're talking about. Okay, let's see, what shape is this? It's going to be a parabola opening down. I want to make sure that I'm clear with my equation. And so does it start at 0? I don't know. What's the y-intercept of this equation? Ah, here it is. There's the y-intercept. So this graph starts at 276, does not start at 0, and it's a parabola opening down. So if I make the width of the garden 0, then all we would have is walkway. We'd have some area. And then as I make the width bigger, the area gets bigger, and then it gets smaller. What is the largest area the garden plus the walkway can have? Garden plus walkway. So that sounds like total area. What's the biggest total area we can have? So here's the graph of total area. That sounds like a maximum. So does that mean they want me to find the h or the k? Total area is the y. They want me to do a k calculation. K equals, give me a c, 276 minus b squared. I'm going to write 40 times 40 over 4a, which is -1. Okay, cancel time. Let's cancel the negatives. Let's cancel 4 into 40 to make a 10. So now we have 276 plus 40 times 10 is 400. So I'm getting an answer of 676. And now I need to put some units on this. Units. This is total area. The area units for today, look up at the top, are feet. So this is feet squared. That's a lot of area for a garden and a walkway. Find the dimensions of the total area. Okay, when I want to find dimensions, I'm going to have to find an h. That's the x value. And that's going to be the width of the garden. All right, looking at our equation, -b is -40 over 2a. So the negatives cancel. 40 divided by 2 is 20. Now let's be very careful here. What does 20 on my graph, what does 20 represent? It represents the width of the garden. That's x. That's x. So I'm going to draw a new little picture here. Okay, here's the garden. Man, I wish I could see all of this at once. Maybe if I zoom way out, you guys can see the original picture and the new picture. Okay, kind of. Okay, so x is 20. That goes inside right there, 20. So the garden has 20. And then what about that dimension of the garden? 40 minus 20 is 20. That gets a 20. And then what about the big length and width? The big one was 20 plus 6. So that's going to be 26. And the new length down there on the bottom, 46 minus 20 is 26. All right, I got a great diagram here, and I want to make sure I answer the correct question. Let's just put a little note here. Be sure to answer the correct question. Okay, so what is the question? find dimensions for the total area. Do they want dimensions of garden or dimensions of the big total area? So that means my answer is going to be 26 feet by 26 feet. Sometimes the question is going to say find the dimensions of the garden. Sometimes it's going to say find the dimensions of the total area. Sometimes it might say find the width of the walkway. So looking at your original picture, maybe drawing a new picture with the numbers would help you do that. Let's take a look at another one. Okay, here's a magazine page. So we've got a magazine, and the pages are 8 by 10. So let's draw a paper that's 8 by 10. That's pretty standard. 8 by 10. 8 top, 8 bottom, 10 inches around the side. Okay, and this is the page. I don't know why, but it seems like all these words when you're doing papers are P words. Okay, the article gets printed with a uniform margin around it. Okay, so if this is your page, this is your paper, we're going to print the article inside of this paper with a margin. You can't print right up to the edge. So inside here, this is where the article is going to go. Article. Okay. And there's a uniform margin around it. So do you know what uniform means? Uniform? I wish we wore uniforms. Everyone would look the same. Okay, same, uniform. So this margin right here, I don't know what it is, but I'll call it X. And then this one right here is X, and this one right here is X. So sometimes your teacher tells you what to make the margin. If not, make them 2 inches, right? Okay. The area for the article is to be 48 inches. So that's the inside. Okay, remember what we said. Whenever you put a border on, you have to state the new length and width. So I knew that it's 8 and 10. Okay, watch my fingers. It used to be 8 inches down here, but this new one is a little bit smaller. So what's the new width? It's not 8, it's smaller. It's smaller. So the new width down here is 8 minus 2x. So I guess if you're going smaller, you'll subtract. The last one, we were going bigger. We had to add on. All right, how about the length? It used to be 10 inches. Okay, but this one is a little bit smaller. So what is that new length? Not 10. 10 minus how much? 2x. Oh, this is tiny. 10 minus 2x. Okay, we got a nicely labeled diagram. Okay, we're writing an equation that represents the area of the article. All right, let's make sure we look at the right thing. Does article mean the little rectangle or the huge big rectangle? It means the little one inside. All right, a of x equals length times width. So we've got the quantity 10 minus 2x. Make sure you put parentheses around the quantities. And 8 minus 2x. Do we have to multiply it out? Yes, we have to multiply it out. So why don't you pause the video or take a couple seconds here, multiply that and get it in descending order, please. Go ahead, I'm waiting for you to do it. So in descending order, I hope you have the 4x squared first. Okay, and how about your outers, inners? Minus 36x, and the constant, plus 80. And what does this a of x here, what does this equation represent? It represents area of just the article, the area of the article. Okay, find the width of the margins. I need some information here. Oh, here's a fact we didn't use. If the area of the article is 48 inches squared, that is the area of the article. So I can put 48 into this area a of x spot, and I can solve the quadratic. So this doesn't say maximize. It says I want the area of the article to be 48. That might be the biggest, it might be the smallest, it might just be some random amount. So it's not a maximizing problem, it's a put 48 into that spot. 48 equals 4x squared minus 36x plus 80. And how do you solve a quadratic? I'm going to get two answers, so I have to move everything over and make a 0. 80 minus 48 is going to be 32. Okay, now it's time to factor. You can factor as is, but if you factor out a 4, yeah, they could all be divided by 4. That would make the problem easier. X squared, 36 divided by 4 is 9x plus 8. All right, this is going to get a lot easier now because it's x and x. 8 has a couple of options. Is it 4 and 2? Not this time. Minus 1, minus 8. Okay, so we have a couple of options. X equals 1 and x equals 8. Now this is inches, yes? Inches? Okay, so inches. And what does x represent? What's x? See x right here? X is the width of the margins. That's exactly what they wanted me to find, the width of the margins. This is an excellent problem. Sometimes what I do is I take a piece of paper to show people how this works. Okay, so if I take a piece of paper, I can cut off margins that are 1 inch from the top, 1 inch from the bottom, and then I can cut 1 inches off from the left and the right. So there's the margins, and then this paper here is where I'm going to print the article, and those are all the margins on the sides. Okay, that's the first option, and let me show you what the second one would look like. So you take a piece of paper, and I'm going to cut off 8-inch margins. So here's the paper, and I need to get 8 inches in. Okay, so I'm going to cut off 8 inches from the right. Okay, and then I'm going to go 8 inches. Oh, this is weird. How am I going to cut 8 inches from the left and the right? The paper's only 10 inches big. That answer does not make sense. Mathematically, we did nothing wrong. It's just not going to fit on the piece of paper. You can't take 10 inches and cut off 8 and 8. How about this one? It's only 8 inches. I can't cut off. So what I want you to do is just to very gently cross that out. I want to see all your work. I want to see that you found it. But then you need to call it something. An answer that just does not make sense when you check it. Extraneous. That's right. An extraneous solution. So I want you to cross it off and label it as extraneous. It just does not work. Does not work. All right, we're going to practice writing some equations here. So we've got this rectangle, and it's 4 by 6 inside. Oh, there's a picture that's 4 by 6 inches, and that's got a frame around it. How cute. Okay, and here's a bunch of directions. Write the equations. So we have to know what this picture's talking about. So it says the poster consists of a picture. So this one right here is picture. This entire thing is poster. And then this is the frame inside. Okay, so this part here is the frame. Okay, write an equation. Oh, you know what we need to do whenever we have a border is label the new length and width. So it used to be 4 inches, but it got a little bigger. So it's 4 plus 2x. And the bottom used to be 6. This length is 6. But the bigger one is how much bigger? 6 plus 2x. Okay. The first question here says find the area of the poster. The poster is the whole thing. So what we want to do is write an area equation with the new length and width. 6 plus 2x times 4 plus 2x. Now let's go ahead and write this in descending order. That's going to be 4x squared first. The outers are 12x plus 8x. That's going to be plus 20x. And the constant is plus 24. That's the entire area. Okay, number 2 says find the area of the picture. The picture's just inside. So the area, oh, this is easy. This is just numbers. 6 times 4 is 24 inches squared. Notice I didn't write a of x. It's not an equation. It's not a function. I don't need an x. I have just numbers. Okay, number 3, area of the frame. Do you guys know how to find the area of a frame? Area of a frame. If you take a rectangle and you cut out the middle, I'm literally cutting out the middle, okay, that's how you get a frame, right? So how do you get out the middle? You subtract the center, and the area that you have left is just the frame. So what I need to do for this equation, a of x, I'm going to take the entire, and I'm going to subtract the middle. So I'm going to write down 4x squared plus 20x plus 24, and the area of the center minus 24. So a of x equals 4x squared plus 20x. Oh, cancel, cancel. And this last one is kind of unusual here. They want me to make an equation that says the area of the frame is equal to that of the picture. So let's get the equation for area of frame. There it is right there. We just made it. So I'm going to say 4x squared plus 20x equals that of the picture. The area of the picture is 24. This just said practice writing equations, but of course on a homework or test I would say now solve that to find x. Okay, so just got to be careful. There's lots of different equations you can make. All right, let's take a look at some factoring here. How do we factor? Some people are good at guessing and checking. Other people like to have a technique. And so if you multiply the outers, the first and the last terms right there, that's the multiply number. Your middle number is your add number, so that's negative 5. So 6 times negative 6 is negative 36. Trying to find the numbers that add up to negative 5. So I don't think it's 1 and 36 or 2 and 18, 3 and 12, 4 times 9. Ooh, 4 times 9 does make a 36, but one of them needs to be negative. Which one? The 9. Okay, now this is where people tend to go wrong a little bit. After you find these numbers, you don't just jump to the end of the answer. You have to split the middles. You split the middle term right here. The negative 5x is going to split up, of course, into negative 9x and 4x, because that makes negative 5. So write your first term, and now we're going to write plus 4x minus 9x. Really, does that add up to negative 5x? Yes. Okay, after you do that, it's just factor by grouping. So then we're going to look at the first two. So stop using parentheses and turn this step into multiply. Just look at the first two or underline them if you have to. We're going to take out 2x, and that leaves us with 3x plus 2. Now just look at the next two, or underline if you have to do something. Try to make duplicates here. They both have a negative. Let's take that away. They both have a 3. Let's take that away. And that gives us 3x plus 2. Perfect. If those match, you're at the end. The final answer is 3x plus 2. Put whatever you have in the duplicates, and the other two go right there. So is that true? 3x times 2x is 6x squared. Perfect. And your last two should make negative 6. Now, how do you make the middle? Negative 5x comes from the outers and the inners. And that does work. Let's try another one. I'm going to make the MA table. For people that don't like the MA table, you could probably just guess and check. Okay, so 2 times 21 is 42, and the add number is negative 13. How do you make a 42? Well, 2 and 21, that's not going to work. Does 3 go in? Well, 4 plus 2 is 6, so yeah, 3 goes in, and we get 14, but that's not going to work. Let's see, how about not 5 to 6 going? Yeah, 6 times 7 is 42. Hey, and those add to a 13, but I need a negative 13, so they both need to be negative. All right, so we're going to come over here, 2x to the 4th. Now split the middles. Negative 13x squared is going to split into negative 6x squared minus 7x squared. Now that is a little different. If you have squareds, they're both squareds. These should add up to the middle. Okay, let's go ahead and take out what we need to. From the first two, we're going to take out a 2, and we can take out x squared. That leaves us with x squared minus 3. From these two, I'm going to take out the negative from the first term there, so he's positive, and I'll take out a 7. That leaves us with x squared minus 3. Perfect. One set is 2x squared minus 7, and the other one is x squared minus 3. I'm going to leave it like this, but in the very near future, I'm going to say factor that more, with radical 3's, of course. Okay, some people probably could have guessed. How do you make a 2? There's only one way, 2 times 1. How do you make 21? It probably was going to be 7 and 3, but then you might have to try 3 and 7 and switch it around to c. But it's definitely x squared times x squared to make x to the 4th. And your outers and inners will be squared, and that's what the middle was. Okay. I'm going to jump down here to number 4. I'm going to factor out, they could all be divided by 3. So I'm going to factor a 3 out from the original problem and make a smaller quadratic, 4x squared plus 4x minus 3. That's going to make everything a lot easier. Okay, so let's multiply 4, your first and your last number. So your multiply number is negative 12, and your add number is 4. How do you make a 12? 1 times 2, 1 times 12, 2 times 6, 2 and 6 make. But which one's going to be negative? The 2? Okay, I got it. Now I'm going to come over here and split the middles. You still need to write the 3. You cannot lose that. I'm still going to put all my work in these big brackets. I'm just going to do the trinomial in these brackets. Your first term gets written down. The 4x middles are going to split into negative 2x plus 6x. It doesn't matter which way you write those. You write them the other way, we're still going to match in the end. Okay, don't forget the 3. If you're somebody that loves to underline, then go ahead and underline. From the first two, let's take out 2x, leaving us with 2x minus 1. Okay, from here, you got to say plus or minus. Plus, I can take out a 3. And that would be 2x minus 1. So right here, if I distribute these two, and then plus distributed these two, you should have 4 terms. You can't have 2 parentheses without a plus sign right there. It's 2 terms plus 2 more terms. Final answer, there's a 3 out in front. At this point, you don't need the brackets. I've got duplicates at 2x minus 1. And the terms that I took out are 2x plus 3. If you'd like to put brackets, you can, but they're all being multiplied. Final answer. Man, I totally skipped number 3. I wish there was someone I knew that could do this problem and then show it to me tomorrow. That's right, it's for you.